The answers to this are also posted in Schoology. I did not give you the answers, but they're posted. I want to do number 3. This is on the review sheet. Number 3. Because something like it was on a homework, I think. And we got issues here, so let's take a look at it. Yeah. Now we need to understand what it means to be odd. What it means to be odd is if you take your function and input a negative or input the opposite, you will output the opposite. So in other words, if you put in 7 and get -4, then if you put in -7, you're going to get +4. That's what it means to be odd. Change the sign on input, changes the sign on output. Okay? Now, let's use, this is the definition for odd right here. Let's use that definition. If, this is my problem, what is the opposite of that? What would negative f of x be? Negative x to the 4th plus 7x, right? So there's part of my definition right there. Now, what happens if I input a negative into this problem? What do I get? I get negative x to the 4th minus 7 negative x, right? So f of negative x equals x to the 4th plus 7x. There's the other part of the definition. Are those equal? No. Your job was to determine if it's odd or not. Your answer is no, right? And what's your proof? F of negative x did not equal negative f of x, and that's what odd means. Now, even means, this is all odd here, even means that if you put in a negative, it doesn't matter. So in other words, back to this example, if 7 gives you -4, then -7 will also give you -4. So even means changing the sign on input does not alter output. The words even and odd are related to, think of your BFFs. Yeah, we're gonna talk about that too. If we let's just pick a number, let's put in 2. If we put in 2, we get 8, right? What happens if we put in -2? We get -8. Changing the sign on input, change the sign on output. Think of y equals x squared. You put in 2, you get 4. What happens if you put in -2? You still get 4. Changing the sign on input does not change output. That's even. Now, as Sir said, this whole idea of oddness and evenness is also related to symmetry. If you have your function and you test for symmetry about the origin, you change the sign on y's and you change the sign on x's. When I clean that up, I get this. Is that the same as the original? No. So that could be another proof for you. Because if you're odd, you have to be symmetric about the origin, and this one clearly isn't. So it can't be odd.
So to find odd, you would just plug in like if you aren't using any numbers, you would just plug in negative x into all the x's for one equation, and the other one you're gonna flip the sign for everything.
Yeah, that's this right here. That's this definition right here.
Okay.
This says plug in, change the sign on your input, and that will change the sign on your output. This is y, so that will change the sign on y. Changing the sign on x changes the sign on y.
So when it's odd, the output should be like the negative, like the opposite of.
Yep.
Okay.
Yep, so they both change. Changing the sign on x changes the sign on y. Yep, that's what odd means. Okay, I definitely wanted to do that one. Does anybody have another one that you see on here that we need to look at? Anybody see anything? Otherwise, I'll just keep going, unless you see something.
I'm still having trouble wrapping my head around like the concept of odd. Would another way to prove it to be like plug in like negative x into all the x's, and then put negative on the y as well? Would that also work, or is that something different?
That was our test of symmetry about the origin.
Okay.
Yeah, and I said that will work.
Okay.
If you can prove symmetry about the origin, that will work.
Okay.
Yep.
Seven.
7 is another proof. We're proving things are inverses. Now, to prove things are inverses, you have to prove that they undo each other. So in other words, when you build them in composition, whatever you started with is what you ultimately end up with. And it has to go in those words. So what that means is, before I do the problem, what that means is, if I build something in composition, if I'm doing this one, I would start with function g, so I'll take a number like 5. G does something to it, like turns it into 6. And then F would have to take that 6 and change it back into 5. That's what it means to be inverses, okay? So to prove that, we simply do the composition with x's. So what are my functions? My functions are, which number is this? 7? So 3x minus 2 over 7 and 7x plus 2 over 3. So if I'm building this composition right here, I'll start with my g function. And then I will take my g and plug it into my f. So that's going to equal 3 times 7x plus 2 over 3 plus 2 over 3. All right, so what happens there? These will cancel, right? So I've got 7x plus 2 plus 2 over 3. Did I copy something wrong? Oh, yeah, wait. That's a minus 2. I copied it wrong. That's a minus 2. Now the 2's cancel. I copied the whole thing wrong, you guys. Sorry, let me back up. Plug this in for the x. So it's 3 times that minus 2 over 7.
And now you're 7.
And now my 7's canceled. Now let me do the other way just to make sure I clean up the mess I just made. So the other one would say start with F. Now plug that into G. So here's my g functions. That's gonna be 7 times 3x minus 2 over 7 plus 2 over 3. And hopefully that'll all be, yeah, so that makes negative x. Okay,
So logically, couldn't you just think of that as my original equation is 4x minus 2 over 7. I multiply 3, divide by 7, subtract by 2, so then the inverse would have to be multiplied by 7.
Yep.
And instead of doing all that,
oh, no, that's not a proof.
oh,
That's not a proof. So, yes, it makes, intuitively, it makes completely good logical sense, but
It's
that doesn't count as proof.
okay, you just have to prove it, okay.
Yeah.
And then
Yeah.
prove it.
Do you have to do it both ways?
You do. It seems very strange, but there are inverse relationships that only work one direction and not the other one. Not so much with functions like this, but we just get in the habit of always doing it both ways.
Okay. You do 6.
6, find the implicit functions. Yep, I wanna make sure when you're finding your own functions like this, make sure you are making notations about any domain. Things going on, okay? So let's keep that in the back of our mind. All right, so here we go. X minus y squared equals 8. That is not a function. What is that? What shape is that? It's a parabola, but it opens
To the side.
sideways.
Yes.
Remember, squareds are parabolas. If there's only one squared in the equation, it's gonna be a parabola of some kind. And since it's y squared, this one's opening sideways, it is not a function. So just think about if you were gonna type this in on your calculator, wouldn't you rearrange the equation and get the y by itself? So maybe
Y equals plus or minus the square root of x minus 8.
plus or minus the square root of x minus 8, that looks good. So my two equations are the square root of x minus 8 and the negative square root of x minus 8. Alright, now let's graph this on our calculators for a second, and let's see what it looks like. I'm gonna graph both these equations. By the way, your window might be screwed up from something or other, so you might wanna zoom 6 just to get a standard window again. Up to you, I don't care, but I don't know how your window is right now. So I'm gonna graph these two equations. Did you get a little parabola clear over there to the side like that?
Yeah.
Is that okay with everybody? Alright, tell me about my domain. 8 to infinity, right? That's my domain. Is that okay with everybody?
On the test, can we leave it as plus or minus? And not
Yeah, yeah, you can leave it as plus or minus. Just understand, if you have to graph it, you need those equations, but yeah, it's fine to leave it plus or minus. Okay, anybody else see anything on there that you're not quite sure about at first glance?
So when it says implicit function, you just want the domain?
Pardon me?
So when it says implicit functions, you just want us to like create, make it.
You always should write down your domain. Any kind of functions you're writing, you should write down your domain.
So with implicit functions, we're just making it into a function?
Yep, you're writing one equation as two that are each functions then.
So will we always have to graph it?
No? You can tell from that equation your domain's 8 or bigger, right?
Right.
I mean, the graph certainly helps me see that.
Yeah.
So you do not need to do like a range, you just need a domain.
or minus kind of covers that range thing, because that's all the positive Y's and all the negative Y's. All right, anybody else see anything on this sheet that we need to talk about? Otherwise, I'm just gonna pick on myself. Ellie?
Page number
10, find all the asymptotes. Okay, well, first of all, we got 3 kinds of asymptotes, but one of them we haven't discussed yet, so it's just horizontal and vertical for us. So right now, we're only looking at horizontal and vertical asymptotes. All right, so how do we find either one? Where do these come from? In the equation, what do I look at? Then, to find the horizontal asymptotes, I examine the highest power in the problem, so I'm looking at the exponents of the highest thing at the top and the bottom. So notice that in this problem, the highest power is x squared, right? Squared. And on the top, I have no x squares. So when I build my little comparison there, I have 0 over 1, which is 0. So my horizontal asymptote is at 0. Horizontal asymptotes are limits. And if you think about x getting really, really big, doesn't that fraction get really, really small? Hence, 0 is your limit or your asymptote. Now, what about vertical asymptotes? Where do they come from?
They come from the x's in the denominator.
They come from what x cannot be, exactly. So if I factor my denominator, I can see that there are 2 cannot be's. X cannot be 0, and x cannot be -2. So this picture would have 2 vertical asymptotes.
This is one of the ones that like, it's just like that, and then there's a collapse.
Okay, now, another thing that can happen, and I can't remember if it's in here or not, but another thing that can happen with a problem like that is you can have something like this. You know, something like this. Wait, we're gonna finish this problem. Now, take a look at it carefully. Certainly, where is the horizontal asymptote?
At 2.
Y equals 2 is my horizontal asymptote. But be careful.
You have to factor.
You have to factor the whole shebang. Because when you do that, what do you notice? When you factor the whole problem, what do you notice? This is going to cancel, which makes it a removable discontinuity, not an asymptote. Your vertical asymptote is at x equals 4, but you're going to have a hole, which is another kind of discontinuity, a removable discontinuity, at -2 comma something. And then the something, remember, we reduced your problem to this. So the something, we're gonna put in -2, -2, -8. Did you get 4/3? You do that right? I think that's right. So you gotta be careful. Vertical asymptotes are cannot be's for sure, but they're non-removable cannot be's. If you can cancel it out, it's not an asymptote, it's a whole.
So if it does that for asymptotes, we need to list like the
No.
whole.
If it asks for discontinuities, yes.